Alright, let's do this. Okay, count total number of cells that are colored. Okay, there's this an infinitely large two-dimensional grid of uncolored cut unit cells. You're given a positive integer n, indicating that you must do the following routine for n minutes. At the first minute, color any arbitrary unit cell blue. Every minute thereafter, color blue every uncolored cell that touches a blue cell. Below is a pictorial. Okay, so sure, return the number of colored cells at the end of n minutes. Infinitely large. Oh my god, are you serious? These are not appropriately medium. I think these are very much on the easy side. Maybe they want you to do this more programmatically, but there's just a straight formula that you can do for these. Okay. I mean, you could do a recursion here, or you can do a for loop that increments the value each time by, but there's just a formula. This is just quadratic formula for this. This n could be 10 to the fourth, and n can be 10 to the fifth. Okay. The formula here is for every, let's see, it's 1, 5, and then 1, 2, 3. So for each outer value, for each perimeter of your shell, you have 2 more for that perimeter. So like the perimeter here, there's 4, and this one contributes 2, this one contributes 2, this one contributes 2, and this one contributes 2 in the next one. I think you can do, well, you don't want to do straight recursion here because that's a lot of stacks. But you could probably do a for loop here. The quickest way is just use the formula. So what would the formula be? So it's 1, 5, then 5 here would be 9, no, 5 plus 9 is 13. Should be quadratic. So I think it's something like n squared. N squared would give you 16 here. The next one would be 6 times 2 plus this. No, 8 times 2 plus this, so it would be 16. 1, 2, 3, 4, 8, 6, 16 plus 13, so that's 29. So 1 squared is 1, 4, 9, and then 16. So if you subtract that, that's 0, 1, 4, and 13. Okay, what's going on here? 13. Let's see. So you start with 1. The outer perimeter is 1. So then you do 1 times 4 plus 1 is 5. And then the outer perimeter there is 4. You multiply that by 4. Now you multiply that by 2. 1, 2, 3, 4, 5, 6, 7, 8. So the outer perimeter is 4. Oh, the special case here is just 1, I guess. 1 doesn't have outer perimeter. It doesn't contribute 2. So here it's going to do 5 plus 4 times 2, so that's 13. And then the outer perimeter there is going to be 8, so it's going to be 13 plus 8 times 2, so that's 16, 13, that's 29. And then the outer perimeter there is 16, so it's 29 plus 16 times 2, 32, 29, 61. Is this quadratic actually? 1, 5. And it looks like it should be quadratic since you can kind of rotate it and see a square. But 1 plus 5 plus okay. Well, let's just do this here. If n equals 1, turn 1, turn 1, see outer equals, let's say n is 2 at least, so outer equals 4, inner equals 1 for I in range of 2 to n. You're going to 2 to n. So if this is n is 1, then you want to do this 0 times. Okay. Your inner is going to be equal to your previous inner, so plus equals 4 times your outer. Your outer is going to equal 2 times your outer. Your inner plus your outer. Sounds like a severance thing. N is 2. My output's 25. What's going on here? Inner equals outer is equal to 2 times your outer. So 4 and then 8 and then each square from there is 1, 2. This thing becomes 1. Oh wait, am I doing this totally wrong? This contributes 2, but then this contributes 1, 2, 3. So this is 3, 3, 3, 3. Wait. I hope it's 25. That's way too big. Your inner equals 4 times your outer. Ooh, yeah, this is not right. I think it's your inner. So your inner is 1. Okay, let's go with maybe instead of outer, let's go with previous is 1, and the outer the previous is. So starting with this one, the inner is 1. And the outer is 4. Let's go with this. So your inner, and the next one is equal to your inner plus your outer. And then your outer, and the next one is 2 times your previous outer. This one contributes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm doing something wrong then, because it actually doesn't double. So it goes from 4 to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it triples for each one of these. There's an extra end here. Outer is 4 times 4 plus 4 times n minus 1. So the n's are always here, and the middle ones are n minus 1. 4 plus 4 times n minus 1. So shouldn't that just be 4 times n? So yeah, if I consider this to be n minus, I'm considering this to be I equals 1, I equals 2, your outer is going to be if your I is equal to 1, your outer is just going to be outer is just going to be 4 times n, and your inner is going to be your previous inner plus that outer one, your previous inner being this one. And next time you do it, your inner is going to be 5 plus 4 times 2. Okay, I think this is slightly off by 1, but I think this is okay. I think I'm going to return. This is off by 1. So this is returning 17 when 17. Was 17 ever an answer? Let's do this be n minus 1. Wow, I'm really slow today. If n is equal to I starts with 1. What the hell am I doing here? 4 times I. And is 9 even a correct answer for anything? So inner. So if this is n equals 2, here I should be 0. Should do it 1 time. Or if I should just do something like this, n minus 1. So your outer originally is 0. Oh my lord. What is going on? What is going on? Okay, so if I consider Let's say n is equal to 2. So I want to have this iterate once when n is equal to 2. So starting at, but I want to treat I as equal to 1. So I, starting at 1 to n. If I starts at 1, the inner is 1, and the outer is 4 times 1. So that's 5. Okay, so let's do a test case here. So let's do n equals 1. That test case should work. Okay. Sorry, test case is 2. When test case is 2, n is 2, I is going from 1 to once. 4 times 1 is 4. This is extra. Inner from the previous one plus the outer is now the inner, so I just return the inner at the end. Okay, I think this is a little slow. I think there should be a direct formula for it. Yeah, okay, let's do the direct formula for it. Direct formula. So let's see the pattern here. Starts with 1, then 5, then 13. So the next one here is 5. The outer one is 3 times 4. No. 2 times 3. No, 2 times 4. N minus 1 times 4. So it's previous plus plus n minus 1 times 4. So start with previous is 0 plus 0. No, we start with just 1. So the previous one is 1 plus 2 minus 1 times 4. The previous one is 5 plus 3 minus 1 is 2. 2 times 4 is 8. So it's 13. Previous 13. Times 4, 12, 13, 25. Alright, let's just do 3, 4, and 5. Flip out. Oh. 3 is 13, 4 is 25, next one should be 41. 25 plus 4 times 4 is 25 plus 16, which is 41. Okay. So if I just rearrange this, so squares are going to be 1, 4, 9, 16, 25, subtract those, 0, 1, 4, 8, 9, 16. So the subtraction ends up being quadratic. So if you subtract something quadratic from your value, you get quadratic. I think that implies it's actually not quadratic. Is there a direct formula? So if you subtract a quadratic from a cubic, if you subtract, let's say, quadratic from a quadratic, let's say you have 2n squared subtracted by n squared, you get another n squared, so now that this is quadratic. So what is the formula for this quadratic? I think I need to go 2n squared. So I'm treating this as, let's say, n is equal to 1, 2, 3, 4, 5, 6. And get that. If you subtract n plus 1 squared, it doesn't really line up. 1, 4. No. So the next one after 41 should be 41 plus 5 times 4, which is 41 plus 20, so that's 61. So if I have 1, 4, 9, 16, 25, 36. Let's say I double that. So I have 2, 8, 18, 32, 50, 72. So I have 2n squared. The difference between those is, subtracting those, would be 1, 3, 5, 7, 9, 11. Okay, so it's like 2n squared minus 2n plus 1. So 2n squared, and this thing is 2n plus 1. But I'm subtracting it, so minus 2n minus 1, so it becomes 2n plus 1. Okay, so the direct formula. And n times 2 plus or minus 2n plus 1. Okay. Alright, cool beans. That was rough. Rougher than expected. Forgot a lot of that quadratic stuff.